Imagine a world where a red traffic light appears as a dim brown spot, green grass blends with autumn leaves, and the blue sky is the only thing that shines with bright, saturated colors. This is what reality looks like through the eyes of our four-legged friends. The question of whether dogs see the world in black and white has interested people for more than a century. And although scientists have long known the answer, myths and misconceptions continue to exist. Let's embark on a fascinating journey into the world of canine vision and discover how our beloved pets actually see the world around them. Let's start with the most important fact. No, dogs do not see the world in black and white, like old movies. This is a persistent misconception that doesn't correspond to scientific data. However, their color perception differs significantly from ours. To understand this difference, we first need to explore the amazing structure of the eye and the mechanisms of color vision. Imagine that the eye is a complex biological camera. At its back is the retina, a thin layer of light-sensitive cells that can be compared to film in an old camera or a sensor in a digital one. This is where light transforms into nerve impulses that the brain interprets as images. The retina contains two main types of photoreceptors, rods and cones. Rods are extremely sensitive to light and allow vision in twilight and darkness, but they don't distinguish colors. Cones work in bright light and are responsible for color vision. And here is where the most interesting differences between humans and dogs begin. Humans typically have three types of cones, each responding to a specific part of the light spectrum: red, green, and blue. This system is called trichromatic vision. It allows us to perceive about 10 million different shades. Surprisingly, such rich color perception is more of an exception than a rule in the animal world. Besides humans, only some primates and, interestingly, marsupial flying squirrels possess trichromatic vision. Dogs have a fundamentally different situation. Research has shown that their retinas contain only two types of cones, sensitive to blue-violet and yellow-green spectrums. This is called dichromatic vision. Essentially, dogs see the world roughly the same way as people with deuteranopia, one type of color blindness, where sensitivity to green and red colors is reduced. What does this mean in practice? The spectrum of canine vision can be imagined as a palette consisting predominantly of yellow, blue, and gray tones. Red appears dark brown or even black to them. Green merges with yellow and orange. But they distinguish blue and violet quite well. An interesting experiment was conducted by scientists from Cornell University. They created a computer program that transforms images to match canine perception. When Van Gogh's Starry Night was passed through this filter, it turned out that dogs see the famous blue sky about as vividly as we do. But the yellow stars look less saturated and more faded to them. But why did evolution endow dogs with this particular type of vision? The answer lies in the lifestyle of their wild ancestors. Wolves, from which all domestic dogs descended, led predominantly crepuscular lifestyles. They hunted at dawn and dusk, when rich color vision doesn't provide substantial advantages. Much more important was the ability to see in low light and notice the movement of potential prey. That's why dogs have many more rods in their retinas than humans. Humans have about 120 million of them, while dogs have up to 160 million. This feature gives them a significant advantage in darkness. Research shows that dogs can see in lighting conditions 4 to 5 times dimmer than the minimum level necessary for humans. Imagine this situation. You take your dog for an evening walk in the park. Twilight deepens, and soon You can barely make out the outlines of trees and paths, but your pet continues to run forward confidently, easily, finding the way and noticing other dogs or small animals. For them, the world is still filled with clear, albeit not too colorful, images, while for you it's already sinking into darkness. Besides better night vision, dogs possess superior peripheral vision. A human's field of view is approximately 180 degrees, while dogs have around 240. This means they can notice the movement of objects that are practically behind them without turning their heads. This advantage was vital for wolves, allowing them to simultaneously track prey and monitor the territory around them for danger. However, nature rarely gives advantages without compensation. Better night and peripheral vision in dogs is combined with lower visual acuity. If human vision is conventionally designated as 100% a conditional unit, then canine vision constitutes only about 20 to 40%, depending on the breed. This means that an object a human can clearly see from a distance of 20 meters. A dog will see just as clearly only if it approaches within 5 to 10 meters. Interestingly, this feature even affects how dogs watch television. Modern televisions with high refresh rates are perceived by dogs roughly the same way we perceive them, as smoothly moving images. But older models with low refresh rates they saw as a series of flickering pictures, which explains why many dogs ignored televisions in the past. It's also worth noting that visual abilities vary significantly depending on the breed. The selection of dogs over thousands of years has led to an astonishing diversity of skull shapes and eye positions, which directly affects their vision. Greyhounds, bred for hunting fast prey, have a so-called visual streak, a special zone in the retina with an increased concentration of photoreceptors. This gives them improved distance vision and the ability to notice moving objects from afar. But brachycephalic breeds with flattened muzzles, such as pugs, bulldogs, or Pekingese, may have a significantly narrower field of vision due to the peculiarities of their skull structure and eye position. Some of them have eyes positioned so frontally that they practically cannot see what's happening at their sides. This is one reason why such dogs may be more fearful and nervous in unfamiliar surroundings. It's harder for them to control the space around them. An interesting fact, dogs with long muzzles, such as collies or German shepherds, possess binocular vision, the ability to see with both eyes simultaneously, in a sector of about 60 degrees, while dogs with short muzzles can reach 90 degrees. For comparison, human binocular vision covers approximately 140 degrees. Now let's return to the question of color perception. How did scientists figure out that dogs see not a black and white, but a blue-yellow world? The history of this research is fascinating in itself. In the early 20th century, the great Russian physiologist Ivan Pavlov conducted his famous experiments with conditioned reflexes in dogs. He believed that dogs don't distinguish colors at all and orient themselves exclusively by the brightness of objects. This opinion dominated science for several decades and led to the formation of the myth about black and white vision in dogs. The first serious scientific studies refuting this theory were conducted in the 1960s. Scientists from the University of California trained dogs to choose objects of a certain color to receive a treat. They carefully controlled the brightness of the objects so that dogs couldn't orient themselves by this parameter. The results showed that dogs do distinguish some colors, although not as well as humans. A breakthrough in understanding canine color vision occurred in the 1990s when scientists were able to directly measure the electrical activity of the retina in response to light stimuli of different colors. These studies definitively confirmed the presence of two-component color vision in dogs. In 2013, a group of Russian scientists conducted an elegant experiment. They trained dogs of different breeds to distinguish colored cards. First, the dogs learned to differentiate dark blue cards from light blue ones, and then dark yellow from light yellow. After that, they were asked to choose between blue, yellow, and gray cards of the same brightness. The results unequivocally showed that dogs confidently distinguish blue and yellow colors, but confuse red and green with gray. This became the final confirmation of the dichromatic nature of canine vision. These studies have great practical significance. For example, manufacturers of dog toys now try to make them predominantly blue or yellow, as dogs see these colors best. But a red toy on green grass is far from the best choice, as they will appear almost the same color to a dog. Interestingly, many trainers and dog handlers have long intuitively arrived at this conclusion. They noticed that dogs find blue or yellow objects better than red or green ones. Now, these observations have received scientific confirmation. However, vision is just one part of the complex system of how dogs perceive the world. To truly understand how they perceive reality, we need to consider other senses, especially smell. The olfactory abilities of dogs are truly phenomenal. Their noses contain from 250 to 300 million olfactory receptors, while humans have only about 6 million. Additionally, the part of the brain responsible for processing smells is relatively 40 times larger in dogs than in humans. This gives them the ability to detect scents in concentrations 100 million times lower than what humans can detect. Some trained dogs can detect one drop of a substance in a volume of water equivalent to 20 Olympic swimming pools. To imagine the world of smells available to a dog, picture yourself entering an unfamiliar apartment. You might feel the general smell of the place, perhaps the aroma of cooking food or the owner's perfume. But a dog, it will know how many people live in the apartment, their gender and approximate age. It will determine if there are other animals and which ones. It will figure out when the owners were last home and what emotional state they were in. It can even know that 3 days ago there was a guest who drank a cup of coffee and ate a piece of cake. For dogs, smells play roughly the same role as visual images do for us. One could say they see the world with their nose. When a dog sniffs territory during a walk, it reads a complex interweaving of scent stories left by other animals and people. Scientists from Cornell University, using functional magnetic resonance imaging, fMRI, found that the canine brain processes human scents differently than the scents of other objects. Moreover, the scents of owners activate the reward center in dogs, the same brain region that in humans responds to pleasant food or favorite music. This is scientific confirmation that for dogs, the smell of their owner truly brings pleasure and comfort. No less amazing is canine hearing. The upper frequency limit that a human can hear is about 20,000 hertz. In dogs, this indicator reaches 60 to 65,000 hertz. Thanks to this, they hear many sounds inaccessible to our perception. For example, dogs can hear an ultrasonic whistle that is absolutely silent to the human ear. They can catch the squeak of bats or the rustling of small rodents behind a wall, and some studies show that dogs can hear the movement of termites inside wooden structures and even detect underground water flows by sound. In addition to a wide frequency range, dogs have an amazing ability to localize the source of sound. Their mobile ears can turn independently in different directions, allowing them to accurately determine where a sound is coming from. This ability is much less developed in humans. Moreover, dogs can distinguish very similar sounds that seem identical to us. For instance, they can differentiate their owner's footsteps from those of other people, even through a closed door. And trained guide dogs recognize the characteristic sounds of an approaching car long before a human notices it. Another amazing feature of canine perception is the ability to detect Earth's magnetic field. A 2013 study published in Frontiers in Zoology showed that dogs prefer to relieve themselves by orienting along the lines of the planet's magnetic field. They align their bodies along the north-south axis if the magnetic field is stable. This indicates the presence of magnetoreception, a sense that humans completely lack. If we combine all these perceptual features, it becomes clear that dogs live in an amazingly rich sensory world very unlike our own. A world where smells have color and depth, where sounds are visible and magnetic fields are perceptible. A world where a red traffic light is not as important as the smell of a person crossing the road, and a thunderstorm is felt long before the first clouds appear. Understanding the peculiarities of canine perception helps us better interact with our pets. For example, if a dog doesn't react to a red toy in green grass, it's not stubbornness. It simply doesn't see it well. If your pet seems overly anxious during a thunderstorm, remember that it hears the approaching storm long before the first rumbles of thunder and much louder than you do. It's also worth considering that many things familiar to us may be stressful for dogs due to their perceptual characteristics. Loud clubs, fireworks, aromatic candles, or strongly scented cleaning products. All these may be perceived much more intensely by them than by us. Interestingly, some breeds have even more specific perceptual features. For example, huskies and malamutes, bred for life in the Arctic, possess special protective eye mechanisms that allow them to comfortably see in bright sunlight reflecting off snow. And some terriers, bred for hunting rodents in burrows, have improved vision in very low light conditions. Let's return to the question of canine color vision. Interestingly, puppies are born completely blind, with closed eyelids. Their eyes begin to open only on the 10th to 16th day of life, and even after that, vision develops gradually. The visual system fully forms only by 2 to 3 months. This explains why small puppies often seem clumsy and poorly oriented in space. They really do see worse than adult dogs. But with age, dogs, like humans, can develop cataracts, clouding of the eye lens. It's especially common in breeds such as Cocker Spaniels, Poodles, Retrievers, and German Shepherds. Cataracts further reduce the already limited color perception of dogs. Fortunately, modern veterinary medicine allows successful treatment of this disease through surgical intervention. Interestingly, dogs were the first animals to undergo operations for artificial lens implantation. Today, such procedures are quite common and allow many elderly pets to regain their vision. It's worth noting another feature of canine vision: increased sensitivity to movement. Their eyes are better adapted to detect even slight movements of objects than to examine stationary objects in detail. This feature was critically important for hunting and safety of their wild ancestors. Experiments show that dogs can detect movement at distances up to 900 meters, even if they don't see the object itself clearly. For comparison, humans notice movement at a distance of about 500 to 600 meters. This increased sensitivity to movement explains why dogs react so sharply to running children, cyclists, or skateboarders. Fast movement automatically attracts their attention. Another interesting fact: dogs, like humans, can suffer from visual illusions. Experiments show that they are subject to the same optical illusions as we are. For example, the Ponzo illusion, where two identical objects appear to be different sizes due to perspective, works for dogs too. This suggests that their brain processes visual information using some principles similar to human ones. Summarizing our journey into the world of canine perception, we can confidently say, the myth that dogs see the world in black and white has been completely refuted by scientific research. Dogs do see colors, albeit in a limited palette, predominantly blues and yellows. But their world is no less colorful than ours, just differently colored. Smells, sounds, movements, and even magnetic fields create for them a rich, detailed, and multi-dimensional picture of reality. The next time you look into the eyes of your four-legged friend, remember, they perceive the world completely differently than you do. And this difference makes our communication with dogs even more amazing and valuable. After all, we've managed to find a common language with beings whose sensory world is so different from our own. In recent years, scientists have been able to create special computer programs and even mobile applications that show images as dogs see them. This helps us better understand how the world looks through our pets' eyes and adapt the environment for their comfort. Thus, training specialists now recommend using blue or yellow objects to teach dogs various commands. Veterinary clinics are beginning to adapt their design, taking into account the peculiarities of canine vision to reduce stress in patients. And manufacturers of pet products increasingly produce toys and accessories in dog-friendly colors. Even in urban environments, there are tendencies to consider the peculiarities of dog perception. For example, some dog parks install special obstacles and trainers in blue or yellow, which dogs see best. And when designing lighting, they take into account that too bright or flickering light can be uncomfortable for canine eyes. Now, when you choose a new toy for your pet or arrange a place for its rest, you can consider the peculiarities of its perception. A bright blue or yellow toy will be much more noticeable against the background of carpet or grass than a red or green one. And calm, not too saturated aromas in the house will create a more comfortable atmosphere for a creature with hypersensitive smell. Thank you for your attention to this fascinating journey into the world of canine perception. I hope you now better understand how your four-legged friend sees the surrounding reality. And although they don't distinguish all the colors of the rainbow, their world is filled with a richness of smells, sounds, and sensations that we humans can only imagine. This difference in perception doesn't separate us but enriches our interaction, making the communication between humans and dogs one of the most amazing forms of friendship in the animal world.